Alright, here goes nothing. It's been a while, so I hope I remember how to say all these new notations. For 3a, we want to show that if f is integrable on r, over ab, then for all epsilon greater than 0, there exists a p such that the upper sum minus the lower sum would be less than epsilon. So, first, knowing that f is integrable on ab implies that if and only if the lower integral, I think is how we say that, of f of x is equal to the upper integral of f of x. Now, we know that the lower integral of f of x is equal to the sup of the lower sum, and this implies that for all epsilon greater than 0, there would exist a partition p sub 1 such that the lower integral of f of x subtract the lower sum would be less than epsilon over 2. And I have a picture on the bottom of this because this is all pretty confusing to me, as it probably is to you as well. Now, before we go down to the picture, we also know that the upper integral is equivalent to the inf of the upper sum, which would imply that for all epsilon, there exists another partition we'll call p sub 2, such that the upper sum of p sub 2 minus that upper integral would be less than epsilon over 2. So let's take a look at that picture. So here is this entire line would be epsilon, and we just cut it in half, epsilon over 2, epsilon over 2. So, and this midpoint here, I believe if I'm remembering correctly, this is what we're calling the lower and upper integral, which are actually equal to each other. So we can see here that the, hopefully, that the lower integral minus the lower sum would be less than this epsilon over 2. Same up here with our upper sum minus our upper integral, less than epsilon over 2. And if we scroll back up top, again, I think this assumption is okay to say. I could be wrong, but since we know that this lower and upper integral are equivalent, we can just refer to it as the integral from a to b. So this implies that the upper sum for p2 minus the lower sum of p1 are less than epsilon. So now we're going to let p star be a common refinement of p. And the reason we need to do this is because we still haven't shown what exactly it is we want to prove. So this common refinement p star is going to be the union of p1 and p2. And if we just scroll down for a minute again to that picture, the reason we want to do this is because we know that if you have a lower sum, that the common refinement of p of that lower sum is actually going to be greater than it. And just the opposite with respect to the upper sum. When we take that common refinement of p, it's actually going to be less than the upper sum. And that leads us to our final argument up here. So, as I just said, the upper sum for the common refinement of p will be less than or equal to the upper sum for p2, which would be less than or equal to the integral of f of x dx plus epsilon over 2. And I'm making that argument based off this line right here, just rearranging some terms. So then next, a little more rearranging of terms, we can actually arrive that this integral plus epsilon over 2 would be less than or equal to the lower sum of p1 plus epsilon. And the way I arrived at that argument was back here on this line, again rearranging some terms, adding the lower sum over to the right here, subtracting epsilon over 2, and then I just added epsilon to both sides. So that way my left-hand side now was this, and of course that makes the right-hand side here. So we know that the lower sum for P1 would be less than or equal to the lower sum for the common refinement, but now that we have this epsilon, I just also, if I'm adding epsilon here, I'm going to add epsilon to this side as well. So we have now shown, though, that the upper sum of P minus the lower sum of P would be less than epsilon. Okay, so moving on to part B, we're just kind of flipping it around. This time, for all epsilon greater than 0, there exists a P such that the upper sum minus the lower sum will be less than epsilon, then F is integrable on A to B. So start by assuming that epsilon is greater than 0 and that the upper sum minus the lower sum is less than epsilon. So using what we know from problem number 2 of the homework, this middle piece right here, the lower integral will be less than or equal to the upper integral. So we know the lower sum for P is going to be less than or equal to the lower integral, less than or equal to the upper integral, which would be less than or equal to the upper sum. So since epsilon is greater than 0, we know that this sort of implies that 0 is less than or equal to the difference between these integrals, which would also be less than epsilon. So then there you have it. The integrals are equal, which means that F is definitely integrable on A to B. I hope that's right. The proof's kind of short. So if you have any questions, let me know. Thanks.